This is an exercise on the exponential properties, just a review of material that you would have covered in earlier lessons that we use in bigger and more complicated problems in Pure Math 30. So first, let's take a look at what we're working with. B to the n is a fairly typical sort of power, and you've seen that sort of thing before, but the terminology goes like this. The b is the base, and for our purposes we insist that the base is not equal to 0, so that's a restriction on it. The n is the exponent, of course, that's not too surprising, and the whole thing is referred to as a power. So it's not technically correct to say b to the power of n, rather it's to say b raised to the exponent of n, and the whole thing is a power. Not a big deal, but for your information. Now the properties themselves, there's 5 main ones, which I'm not going to derive here. I'm just, because you've seen it all before, I'm just going to present them and then go through some examples that require them. So the multiplication rule is where we're multiplying powers with the same base together. So b to the x times b to the y, the rule is you add the exponents. So b to the x plus y. I remind you that the bases must be the same. The division rule, very similar. B to the x divided by b to the y is equal to b to the x minus y. So when we're dividing powers, we subtract the exponents. And of course, you're very likely to see it in this form. B to the x divided by b to the y is b to the x minus y. So typically it'll be written in that second way, but not necessarily. The power rule is, or as it's often called, is what we call expressions where we have one power in brackets raised to another exponent. So b to the x to the exponent of y is equal to b to the x times y. So here we multiply the exponents. The power of product rule is when you've got 2 or more bases being multiplied together within a bracket raised to an exponent. So a times b to the exponent of x is equal to a to the x times b to the x. So the rule is basically about that x, that exponent outside the brackets, affects everything within the bracket, assuming that those a's and b's are being multiplied together. And the next one that's very similar to it is the power of quotient rule, where you have a divided by b in brackets to the x, and the x here also affects everything within the bracket. So a to the x divided by b to the x. So you use these last two rules when you're clearing brackets. Now there's a couple other rules that are properties that are related to all this. The first one is the 0 exponent. It's the easiest thing you cover this course. And it's simply that anything raised to the exponent of 0 is equal to 1. So b to the 0 equal 1. A little bit more complex is your negative exponent. And a negative exponent the rule goes like this. B to the negative n is 1 over b to the n. And a negative exponent is in the wrong place. So if you see b to the negative n, to make it in the right place, you go 1 over that value. Same thing would be true if you had the negative exponent on the bottom. To make it positive, you bring it to the top. So technically it's not possible to have a negative exponent. It doesn't mean anything other than the power is in the wrong spot. So let's simplify a few of these questions. I'll work through a few of these. 3x squared y to the 4 raised to the exponent of 4. This is an example of the power of product rule. This is 3 times x squared times y4. And we have to make sure that that 4 gets multiplied into everything, including the 3 to the 1. Now you never multiply a base by an exponent. Like you don't go 3 times 4 is 12. But you do go 1 times 4 for exponents is 3 to the 4. And then you go x to the 2 raised to 4 is 8. And then y 4 raised to the 4 is 16. And then with the numbers, you've got to simplify them. So 3 to the 4 is 81. You can use your calculator for that if you're not sure, but you will get very good at that in the course of this unit. 3 to the exponent of 4, that's your exponent key on your calculator, will give you 81. And then nothing else can be simplified because the bases are different. Second one, here we must clear the brackets. So that 3 needs to go through each of the bases within the bracket. So it's 2 to the 3, then it's x to the 4 times 3 is 12, so the power rule again. Then y to the 3, z to the 18, then multiplied by 3 to the 2 times x to the 2 times y to the 8, 4 times 2 is 8, times z to the 3 times 2 is 6. Now you can do this very quickly, most of you will, but I'm going to do it in a few steps. I'm going to put the numbers in the front, 2 to the 3, which is 8, times 3 to the 2, 9, and then I'm going to get the x's taken together, because we have x to the 12 times x to the 2. Now they could be gathered very early on, but I'll write them like that and then add them. And then y to the 3 plus 8, and then z to the 18 plus 6. 2 to the 3 is 8, as I said, times 3 squared is 9, so that's going to give us 72, x to the 14, and then y to the 11, and then z to the 24. And that's all we can do. Very important that you're careful with these as you do them, because you cannot check your answers as you go. You have to do it right pretty much the first time. There's no reasonable answer for any of these. Now this one I chose because of the negative exponent. And there's two ways you can approach it. One, which is the more traditional method, which I'll look at for question 4. But this one I'm going to do a little faster method. Because I see that it is all being raised to the negative 2, it occurs to me that I could take the whole thing, negative 2x to the 3, y squared z, and raise it to the exponent of positive 2. Now notice I didn't change a thing in the brackets. The only thing that changed there was the negative 2 outside. And then this would become, now be really careful, because negative 2 squared, I'm going to write that out separately in little brackets. You don't need to do that. But you do need to be aware that it's a negative 2 being squared. And then this is x to the 3 times 2 is x to the 6. Y to the 2 times 2 is 4. And then z to the 2. And then negative 2 squared is 4x to the 6 y 4 z 2. And there you go. So that works well. There is another choice though, and question number 4 we'll see that. See here we have to clear the brackets, but I'm not going to take that first bracket down, even though I could, and write it with a positive 3. I'm going to do the more conventional thing, and I'm going to just run that negative 3 into all the terms. So 2 to the negative 3 times x to the negative 6, so I just multiply in all the exponents, y to the negative 9, and then z to the 6. And then on the denominator it becomes x to the negative 4, y to the 12, z to the negative 8. And I'm going to insert this step. Now some of you will bypass this because I know what you're thinking. You're thinking, well, we can just use the division rules right now to clean this up, and you can. But I'm going to be a little more conservative about it. Everywhere I see a negative exponent, I'm going to draw on the fact that it's in the wrong place. So that 2 to the negative 3 on top, I can bring it right down to the bottom as 2 to the positive 3. And the same thing is true with the x's. This x to the negative 4 on the bottom that I see right there, I can bring that to the top and write it as x to the positive 4. The x to the negative 6 on the top, take it to the bottom, becomes x to the positive 6. Take that y to the negative 9 down, it becomes y to the positive 9. There's already a y to the 12 down there. The z to the 6 stays where it is. The z to the negative 8, because it's got a negative exponent, we bring it to the top. And see, now I just have to gather up all the negative and positive. So I usually just draw my bracket sign. 2 to the 3 is 8. The x's. Now you can subtract the exponents now, but what I'm going to do instead is I'm going to think, I've got 4 x's on top, I've got 6 on the bottom. So if I divide it out by x to the 4, I would be left with x to the 2 on the bottom. And by this, I don't ever need to deal with negative exponents. And then 9 plus 12 is 21 on the bottom. And then z to the 6 plus 8 is 14 on top. And there we go. So that's a useful way to simplify those expressions. Now, this is not a test question, but you do get lots of quick little, you have to be good at all these individual steps, even though you probably won't be required to do something as massive as this. Number 5, a plus b to the 5x plus 1 over a plus b to the x plus 7. This is a case where it's a simple question, but it's easy to make a mistake. You're dividing powers with the same base. Now, you cannot take that 5x minus 1 exponent and bring it into the a and the b because there's a plus sign. There are no rules for addition of terms. So your only hope is to take this a plus b with the base and then subtract your two exponents. So 5x minus 1 minus x plus 7. Very important to put that bracket up. Many people forget, and of course you get the question wrong. This is now a plus b to the 5x minus 1 minus x minus 7. So you need to put the bracket up because you're subtracting both of those terms, not just the x. And now it's a polynomial question. A plus b, 5x minus 1x is 4x, minus 1 minus 7 is minus 8. So a plus b to the exponent of 4x minus 8. Number 6, this is the sort of question you're going to see, or the skill required in a lot of 30 pure questions. Thing of it is, you can do nothing the way it is. You can't multiply powers together if they don't have the same base. So that means we have to express each of these powers with a base, in this case, of 3, because 9, 81, and 1 over 27 can all be written with base 3. So let's do that. This becomes 3 just to the 1 times 9, which is 3 squared, to the x minus 1, times 81, which is 3 to the 4, raised to the 2 minus x. And then 1 over 27 needs to be written with a base of 3. You probably can see that this is equal to 1 over 3 to the 3. But we don't want a positive 3. We need to have that as, or excuse me, we don't want to have 3 on the bottom. We can't have it as 1 over 3. This has to be written with a negative exponent, 3 to the negative 3. And if you work backwards, you can see that's correct, right? 3 to the negative 3 is 1 over 3 to the 3, which is 1 over 27. But that was necessary. And now we can clean up those exponents a bit by using the power rule that multiply this 2 into the x minus 1, because that is the rule with it. And so you get 3 to the 2x minus 2 times 3 to the 8 minus 4x times 3 to the negative 3x. And because we're multiplying these powers together, we can now add everybody. 1 plus 2x minus 2 plus 8 minus 4x plus negative 3x. This will give us, if you get all the like terms together, 2x minus 4x minus 3x will give you minus 5x. And then the numbers, 1 minus 2 is minus 1, plus 8 is plus 7. So getting common bases is something we do a lot of around here. Now the next batch of questions, just a few of them, is to evaluate the following. Evaluate typically is used when you actually get a numeric answer for it. Now 4 to the negative 3, the traditional way to solve this is to get rid of the negative exponent by writing this as 1 over 4 cubed. And 4 cubed, 4 times 4 times 4 is 64. So that'll always work, and you want to be able to do that. It's not that hard of a question. But some people on their calculator will just go 4 to the exponent of negative 3, and then they'll use their fraction key, which is if you press math and then fraction, I think is the very first one. I don't have my calculator out right now. But it'll take that decimal and it'll convert it to a fraction and take you to 1 over 64. So you've probably seen that a fair number of times before, at least that key, but it does come in handy for these. Other questions, question number 2, 3 over 4 to the negative 2. You could also use your calculator, just go 3 divided by 4 to the negative 2. I'm not going to, I'll be traditional with it. I'll take that 4 to the negative 2 and take it to the numerator as 4 to the positive 2. So this becomes 3 times 4 squared is 16. 3 times 16 is 48. Two-thirds to the negative 4. A couple ways you could approach this. The longer method is to apply the power of quotient rule, which means that negative 4 affects everybody. 2 to the negative 4 over 3 to the negative 4. And then recall that your negative exponents have to be put in the proper place. So the negative 3 to the negative 4 comes to the numerator. 2 to the negative 4 goes to the denominator. And then you work them out. 3 to the 4 is 81. 2 to the 4 is 16. Now that's fine. But most people just flip the base. So when you see 2/3 to the negative 4, you can just write that as 3 over 2 to the positive 4, which will give you 3 to the 4 is 81 over 16. So it works out very directly like that. That's what most people end up doing. Now this is kind of a specialty question, number 4. Thing of it is you got a subtraction sign, so there's no rules that you can apply immediately, at least to the whole thing. Because some people want to take that 5 to the negative 1 and bury it, 3 to the negative 2, bring it to the bottom, 4 to the negative 1, bring to the top. But because of the subtraction, you'd have to be really careful if you did that. So the best approach is actually to take this and work through each one with a negative exponent. So like this becomes 1 over 5 to the 1 minus 1 over 3 to the 2, all over top of 1 over 4. You can probably see where this is going. You see, this becomes 1/5 minus 1 over 9 all over 1 over 4. And it's a complex fraction. So your only hope is to get a common denominator for that numerator, which you can do because 5 and 9 would have a common denominator of 45. And then you multiply, in this case, by 9 over 9 to get that common denominator, so that becomes 9. And in this case, multiply by 5 over 5. So that's 5 over 45. So that's 4 over 45 minus 1 over 4. So 4 over 45 divided by 1 over 4 is multiplied by the reciprocal, 4 over 1. So that gives us 16 over 45. And then we're done. So that's the nature of these problems. The next lesson we'll concentrate on things like fractional exponents, and eventually we then get into things like exponential equations. So some of the basic skills that we use for the student. Thank you for your time.